Let us continue with our project. So in this section we will perform the EDA. So here we will do data analysis to better understand the data set, to identify some patterns and to detect some anomalies. This will help us to gain some insights that will further help us to improve the model performance. So first of all, we will do statistical summary. For that we will use code df.describe. So df.describe. See here, whatever the numerical values were there, we got a statistical summary about it. So we observe here that credit score is having a average value of 650. So on an average, people are having moderate credit score. The average age of the customers, it is 38, wherein minimum is 18 and maximum is 92. The average tenure is 5, and the has credit card. Here we can observe 70% of the customers, they are having credit card, and only 51% are the active members. So these are some of the initial insights that we can gain from the summary. Now let us check for the missing values. So let's put the heading checking for missing values. For this we will use df.isNull.sum. Here we observe that there is no missing value in our dataset. So our dataset is of a good quality. We don't need to do anything in this portion. Now let us check the distribution of the target variable. Exited is our target variable. So we will try to check how it is distributed. This will give us an idea of the class imbalance, whether our dataset is balanced or imbalanced. So checking the distribution of the target variable. So we will simply do df of our target variable is exited, and we will get the value count of the values, value underscore counts. Now here we observe that 2000 values are of 1, 2000 people have churned, exited, and 7900, approximately 8000 people have not exited. So it is imbalanced. Approximately you could say it is about 79. 80% of the people have not exited the 80% of the people have not exited the bank. So this imbalance we should consider during our model training. We should be aware of it. Now let's plot some graphs. So first we will do univariate analysis. Univariate analysis means single variable will be analyzed. So let us see the distribution of age. We will plot some graphs, and again we will try to draw some insights from it. So generally we try to identify patterns and skewness, whether it is normally distributed or not, and whether there are any outliers in the data set. So generally we will be using histograms with kernel density estimation, and these will be applied only on numerical features. So we will be doing on 3 features. Let us first begin with age distribution. So the code for this is plt.figure and fig size. You can give any figure size that you are comfortable. I will simply give 8 and 5. Later we can adjust it as per our requirement. Now I will use sns.histplot. Here I have to provide what I want to display. So df of age. I want to plot df of age. I will give the size of the bins and I will say KDE is equals to 2. Now this will plot it. Now I will just put the labels. So plt.title, distribution of age, plt.xlabel, here I will put x-axis will be having age, and plt.ylabel, frequency. Finally, we will show plt.show to display the plot. So here we have our graph. Let me just make the size a bit small, 5 and 4. Okay, now it is visible. So from this we can make some conclusion that most of the customers, they are between the age of 30 and 50. And the distribution, you can see this line that it is slightly right skewed. That means that fewer older customers, means less older customers are present in the data set. Let us now, so this is the insight. Let us move to the next variable. Next we will do balance distribution. We will check the balance distribution similarly. Again, same we have to use plt.figure, fig size, let's use 5,4. Again, sns.histplot, now here I want to display balance. I was having balance here. df of balance, KDE is equals to true, and C. Simply it has printed it here. I'll put the labels also similar to this. Distribution of balance, X label is balance, Y label is frequency. So from here we can make a conclusion that the balance it is like a large number of the customers. We see this one huge line here. This is having 0 value. So a large number of customers, they have 0 account balance, while the remaining customers, their balance is distributed towards 80,000 to 50,000, 150,000, from here to here, this portion. So this is the conclusion. Let us now check the credit score distribution. Similar to this, we will do, I will simply copy this and paste it here. plt.figure sns.histplot. Here I will use credit score. Distribution of credit score, and Y label is Y label will be frequency only. This will be credit score, and plt.show. Let us see. So again we have our plot. So from this plot, what conclusion we can make is that it is normally distributed, and most customers, they are having score between 600 to 700, and mean is somewhat around 650, that we had seen in the summary also. So now let us do analysis of our categorical features. If you remember, we were having two categorical features, geography and gender distribution. Gender. So we will see that these two distributions. So let us first see geography distribution. In case of categorical, we will be plotting the count plot. So plt dot figure fig size equals to 5,4 seems to be good. SNS dot count plot. Now X will be my geography. To avoid any, I will copy it from here so as to avoid any spelling mistakes. Equals to geography, and data equals to df. So here we have our plot. So we see that Spain and Germany, they are having, so basically there are three countries, and Spain and Germany, they are having somewhat equal number of people, but France is having highest number of people. Here this the width of this bars are a bit more, so I will just make it a little bit thin, so as for a good visual display. Width equal to, I will put it as 0.3. Now it looks good, and size also can be reduced to 4,3. Okay, there we are.